Some final comments on histograms here before we wrap up. When we see the histograms, there's often some characteristics that kind of pop out at us. For example, in the upper left one, the bin that has 0 to 20 has a lot of responses, and then it kind of tapers off. Then the one in the upper right here, it kind of has like two humps to it, and then the bottom middle one looks kind of like a single hill with a little, well, okay, there's a little dent in the peak, but that's fine. When we talk about histograms, there are these features that we want to describe, and so we capture them in under these 5 general categories. We want to, when we talk about a histogram, we want to first describe any striking deviations. And so you might be familiar with the term outlier or extreme value. I don't want to use outlier because in statistics there is a particular meaning associated to an outlier. So we're just going to say potential outlier instead. So for example, do any of these have a striking deviation or a potential outlier? Anything that is far from everything else, that's what an outlier is. Well, a potential outlier is. Well, maybe. I'm going to let you decide. The next thing that we can describe is the shape. So is it, is it flat? Is it like just if you are on a plateau or on a flat level ground? Does it look like that? Are there hills to it? Are there, and those hills we talk about as modes, as frequent values, or we can also say peaks instead of hills, but they're the values that are most frequent in a data set. So where are those? We can also talk about where it's centered, like if we were to imagine it balancing on a teeter-totter, where would that balance point be? Spread, is it kind of clustered all close together around a certain value, or is it very spread out? And the last thing that we want to discuss is this idea of skewness. Okay, so skewness might take a moment for you to think about, but if there isn't any skew, what we would say in absence of skew is that it would appear symmetric. So you could fold it down the middle and it would mirror itself. Okay? Skew to the right. What that means is that the right side is going to have extreme values. There's going to be a tail. Okay? So graphically, what we would see for a skewed to the right distribution is something like there's a hump over here and then there's a long skinny tail off to the right side. Okay, so the right side has extreme values. Conversely, if the tail was on the other side, we would say it's skewed to the left. So a left skewed distribution would look something like long extreme values to the left, and then we get a hump of values or frequent values off over to the right. Okay, so there are more extreme values to the left side, or the more extreme values are smaller. Okay, so just be aware of those pieces of language that we can associate to graphs. So what pieces of those 5 things can we say here? Well, in the upper left one, I would say this, in terms of the skewness that we were just finished talking about, it kind of looks like there's a tail that goes off to the right. So I'm going to say this is skewed to the right. Sometimes people just say right skew. Okay, there appears to be a single peak, so I'm going to call that unimodal. Okay, for 1. 2 modes would be bimodal. More than 2, we would just say multimodal. Okay, so this one, for example, I kind of see 2 humps. I would say this one is bimodal. Okay, you could talk about center. You can talk about spread. And I would say, yes, this one probably is a potential outlier. Just because it seems far from everything else. But the center and spread I have to identify. So, this one, your guess is as good as mine. Believe it or not, the center is not going to be in the most frequent value just because you need some more to balance that. So I actually anticipate that the center would be around 40-ish. And then the spread, this one, considering you have observations from 0 to, 140 or more, I would say it's going to be a large spread. We can quantify this in chapter 2, but right now we don't have the ability to do that. Okay. So I did one. I wonder what you can come up with for the other two. So I want you to try to talk about those 5 characteristics in each of these remaining histograms. I talked about the shape with the second one. I said it was bimodal. Okay, what about the others? Pause the video, try and identify, the shape, center spread, skewness, and then any striking deviations. So here's what I wrote down. Certainly, you could have different things and still be okay. So the one in the upper right, bimodal center, I put it at about 35. Again, we can describe that more precisely next chapter. So if you have a rough idea, that's fine. Spread, this one, I'd say it's kind of spread out, but not in a large or small way. This one, I could see somebody saying that it's skewed to the right slightly, but it's definitely not symmetric. But I also think it's not really skewed. And I also said that maybe this is a potential outlier. Again, without, or we can follow these up with more precision later on once we have more tools. Okay. And our last example here, I would say it's probably unimodal, even though this is down a little bit, it's still probably unimodal. Center, about 14, spread is small. It does appear fairly symmetric. It doesn't have to be perfectly symmetric. And I would say there's no outliers. Okay, so again, these are all good ideas or good guesses. We would follow these up with more precise descriptions later on. Okay, so besides that, that's all I have on histograms. Last thing I need to emphasize is that in your graphs, make sure to label. Okay, please, please, please label everything. We are picky / I am picky about everything in the graph. I need to know what the axes are. I'd like to know units. I didn't include units just because our examples didn't really have them. But if there are units, include them. The more information you can convey on a graph, the better off you will be. And the more appreciative your colleagues and those reading it will be as well. So just include labels.